Sorry, guys. So now that we know that everyone's in the right room, I'm Abraham Almari. You can call me Abe. I work at Cloudera on the data ingest on the Ingest team. I'm a Scoop PMC member and an H-Trace committer. And today we're going to be talking about big data ingest systems and some of the lessons I've learned designing them through my years. So I want to know, can everyone hear me well with the noise? Wow,
We're good.
Okay.
I don't know about anybody else, but I can hear it. That's all I care about.
We're going to do our best. I'm going to hold this microphone as close as I can to my mouth. I'm sorry, guys. Okay.
Or the other one we can try is how to model anything. That's the one
So,
my professor was going to.
by the way, stop me if you have any questions, because I know it's very loud here.
Let's check him out for a couple minutes and see what's going on.
So we're going to start off with an overview of some big data ingest systems. Then I'm going to dive down into some of the lessons I've learned from real-world examples, things that I've actually worked through, and we're going to talk about those things and some of the details I kind of picked up along the way. And then we're going to talk. Then I'm going to summarize all of this at the very end of the presentation. Hold on real quick.
Oh, there's a book signing right next to you, so that's the other. Yeah, the reception and the book signing's happening.
We're going to see if we can quiet down the other area, because I think it's very hard to hear.
This is just a lot more successful than they thought it was going to be.
Well, that's not really a horrifying thing.
Okay, we're going to do our best. Okay, so to kick things off, so what makes up a big data ingest system? Now there's a lot of components to it, and this is going to be a little bit high level. I'm not going to go into very big details because I want to focus more on the lessons that we've learned over the years and some of the more interesting intricacies of the business use cases that I kind of came across. So big data ingest systems are comprised of data sources, schema, and speed. Again, there are a lot more details involved in this. For example, if you've read the paper on mill wheel, then you might have seen that things like at least ones, at most ones, exactly one semantics, etc., are also very important. And we'll talk a little bit about that, but I'm not going to dive deep into those. But keep in mind, when you're building the data ingest system, you have your data sources, you have the schema, and you have how fast you want that to happen. So, data sources. What's interesting about data sources? What kind of data sources are out there? So, there are all kinds of different data sources. For example, the GitHub API could be considered a data source. I think the most popular example of a data source is the Twitter APIs, where you actually have a stream of, I think, like 1% of all tweets that are happening on Twitter. You can pull that information. Just the other day, I was hearing Guild Wars 2, if you're familiar with that video game, has an API that you can parse. Can you guys hear me?
Yeah.
Cool. So Guild Wars 2 even has an API that you guys can connect to, play with, etc., etc. I think there's like business data, there's all kinds of financial data, there's a ton of different data sources out there to play with. Some of those are best accessible in a very slow manner, some of those are best accessible in a very fast manner. So when we're talking about data sources, in my mind, there's kind of one big thing that really stands out. Whether the data source is structured, semi-structured, or unstructured, or as I like to think of it as eventually structured. So in a structured data source, you have data that's effectively has something, it looks a particular way. So let's take a spreadsheet. A spreadsheet is structured. Does that make sense to folks? It's tabular, it's got cells, we know exactly where the data is and we know how to pull data out. Does that make sense? Cool. Then we have semi-structured. If you think about JSON, XML, EDI, if you're familiar with some of the kind of older serialization formats and stuff like that, that's kind of a semi-structured way of how to look at things. And then we have eventually structured, which is effectively things are unstructured until we give it a structure. And then we have schema. So there's some interesting things about schema. You know, the number of schemas that a data source might have, or the number of schemas that data might have, how mutable it is, and if the schema is known explicitly or if the schema can be inferred. I don't know if that makes sense to folks, but the idea is that if you can infer a schema, that means that you may not need to explicitly define it. And if we look at big data these days, you don't always have a schema.
Right.
Oftentimes with big data, you have no schema at all, and you have to do things like data mining to pick up little bits of information and kind of provide your own schema, if that makes sense to folks. And so when I say number of schemas, by the way, I'm actually talking about there may be a high-level schema, there might be nested schemas, and deeper schemas. And if you folks are confused as to why this might be business use cases, I'm going to get to that in a moment. We're going over the basics. And so a different way to kind of handle, the various ways to kind of do data ingestion are kind of threefold. We have, twofold. We have batch and real time, or streaming as you guys like to call it, right? And so if we have a batch model, it means that it's initiated in some way, shape, or form. Whether that be scheduled or whether that be user initiated. And for real-time systems, I've noticed two different distinct models. There's the push model and the pull model. So with the push model, you actually have agents pushing data down into some other system. And with the pull model, you have workers pulling from some kind of queue, pulling data out of that queue and processing it or doing something with it, and then putting it elsewhere. So far makes sense? Wonderful. Okay, so that was kind of the high level. I just want to make sure that everyone understands what the big data ingest system is. There's no questions there. Very high level. Does that work for folks?
Populate websites within.
So what are some of the kind of real world scenarios out there? So I used to work for a advertising agency, kind of like a web advertising agency, like a web shop, if you will, where we would work with various clients, various customers, to kind of build landing pages and build out a marketing presence on the internet. And so, albeit it's a very simple use case, this in and of itself is kind of the beginnings of data ingest. When you have data, when you have users fill out forms, that data you're moving directly into a database or logs. That is data ingest at a very basic and primitive level. So that's effectively what I was designing. I was designing a system for generating forms that you could use with these landing pages. And so this was actually really interesting to me for a couple of reasons. Well, for one big reason. You needed to structure your endpoint wisely. If that makes sense to you folks. Basically, there were several different designs that we were considering, but there were two that really stood out at the end of the day. We had the design where we had a many-to-many relationship, where one table would hold all form values, and we'd have one table for form definitions, and we had a table for field definitions. So this was a really interesting design, but I didn't really like it because I thought it was very hard to parse and I needed to use SQL and stuff like that. SQL's awesome, but I wanted something very easy to kind of peer into. I was a developer. So then I looked at this other kind of way of doing things, which is I actually had a table per form. I mean, this in and of itself is kind of dangerous because a DBA will tell you, hey, giving something the ability to create tables is fundamentally wrong, but I thought it was good. And it worked out very well. So the form generator, by building this very simple system called the form generator, something similar to Wufoo, if you guys remember Wufoo, actually made our company a lot of money because we were able to just plug in this piece and we didn't have to do a lot of development. So the big thing here is structure your endpoint wisely. If I had chosen the system on the left-hand side, well, I think it would have been a lot harder to debug.
Right.
The system on the right-hand side is much easier to debug. make sense to folks? Also, the system on the on the left-hand side didn't really have type definitions, whereas the system on the right-hand side had type definitions. So I understood what the type of the data was, which is absolutely important. It means I could validate the data as it came in. Structure your endpoints wisely. So another real-world example, this actually comes from when I was just hacking on stuff and looking at stuff to do. Was I took the GitHub APIs and I pulled a bunch of data out of it. So the idea was I wanted to understand what were the trending repositories. I wanted to know what was getting the most contributors, how fast they were growing. So specifically, I was looking at repositories that were growing fast. So I was looking at the deltas. I was looking at the first order coefficient, if you're familiar with the mathematical terms. I was looking for the deltas. I wanted to know which one was going to be the next big thing. And I wanted to know why.
Yeah.
So here's an interesting example. Have you guys heard of the project called Django? Python Django? I'm seeing some nods. I'm seeing a couple of shakes, but a few nods. So Django is really popular. Really popular. But I think back when I was doing this in like 2010 or something, maybe 2009, I actually found that Django wasn't the fastest growing project, but it was one of the faster growing projects. By that time, in 2009, 2010, it had been established and there were a lot of contributors, even though it was growing rapidly. So I thought that was really interesting. Something that was immensely popular wasn't necessarily the biggest growing thing. I don't know, these things are very interesting. So, now the question becomes, how do we actually do that, given the GitHub APIs? So my implementation was super naive. My implementation was a cron job. Very, very basic cron job, where I basically contacted the GitHub APIs, I found out what my diff was, and then I actually did some real data ingestion in the third step. So 3 steps: cron, scan, scrape. I'm sure you guys have seen this before. There's better ways to do this. So, what did I learn from that experience? So, it turns out that something as simple as scraping GitHub had a lot of complex problems, very intricate problems. So, for me, I didn't really have to worry about things like exactly one semantics. I didn't have to worry about, oh, did I get that record and only that record once? Because if I got that record twice, it means I just reprocessed it. It didn't really matter because the point of the exercise was to actually just get the data and kind of process it like on the fly, understand what's going on, and input it into my database. Very simple process. And so what I learned was the cost of reprocessing is kind of low in some cases, so why not just reprocess on the fly? So at least one semantics is sometimes good enough. And so exactly one semantics, by the way, in contract is oftentimes not feasible. If you guys have looked at exactly one semantics and systems that provide that, I think you'll find that exactly one semantics is very difficult to implement.
Yeah.
Oftentimes you have to deduplicate. So there's a cost. There's a cost when you're building these systems. And so if you're designing a very big ingest system, it takes a lot to do that.
Yeah. The skills aren't moving.
So for me, a better implementation is MapReduce. It involves MapReduce and Uzi. Although I don't know how many people actually like Uzi. But for me, that's a better implementation. And my favorite implementation is Scoop 2 in place of MapReduce. Does that make sense? Cool. Okay, so another lesson I learned from this experience is CDC is very hard, like extremely hard. Change data capture. What this means is that whenever there's an update to the data source, needing to capture that is extremely difficult. So if you're Google, for example, and you need to scrape the entire web, how do you capture all of those differences? Well, they have to scrape the entire web effectively to capture the differences. They also have services called pingers, where they pick up whether or not a website has
within a corporate structure.
If that makes
He's
sense.
kind of hacking through.
So change data capture is very, very hard. And so the real big real world example that I feel like is very interesting, and kind
That
of
explains
the reason that I put this talk under business use cases, is the ad attribution system. So just to kind of get an idea, how many folks are involved in the ad space? Okay, quite a few. So how many of you folks have built real-time bidding systems, attribution systems, and things like that? Or are aware of them? Okay, so we got one. Okay. So folks, I think you'll see that it's actually kind of a difficult thing to build these systems. Especially when there's money involved. If there's money involved, you have to be right, which sucks. It's hard to be right. And so that comes to, I think, my first lesson from this particular example: know thy SLA. So when you're working with